The next part of our journey with logarithms is solving logarithmic equations and exponential equations, and that's what 3.4 is about. And when we're solving logarithmic or exponential equations, we have three strategies. The first one is if we can rewrite anything to use those one-to-one properties, meaning that if you're taking at the log base 5 of both sides, well, then you can just set the logs stuff inside the logs equal to each other. Or if you have, you know, an exponential function and your bases are equal, like here, if we have a to the x power equals y to the x power, then that means the exponents must be equal since the bases are equal. So we're going to be working on that today. We mostly use that with exponential functions because we can rewrite numbers as different bases, but it is applicable to logarithm equations as well. And then we can rewrite an exponential equation in logarithmic form, and that's what we're going to be focusing on today, strategies number 1 and 2. Tomorrow, we'll rewrite logarithmic equations in exponential form in order to solve those types of equations. So what we have here, example 1, we're going to round to the 1,000th when needed, so that's 3 decimal places, and checking for extraneous solutions. Now, when we have extraneous solutions, that's when we plug in the original value back into we plug in the solved value into the original function to see if it still works out. That will mostly apply to logarithmic equations because we can't take the log of a negative number, but we should still do it for exponential equations as well. So example number 1, we have 4 to the x minus 5 power equals 64 to the x plus 2 power. Now, we can rewrite 64 as 4 to the third. So we have 4 to the x minus 5 equals 4 to the third to the x plus 2 power. Well, we know that when we have a power raised to a power, we multiply the powers. So 4 to the x minus 5 equals 4 to the 3x plus 6, because that 3 gets multiplied to both things. Well, now that the bases are equal, we can set the exponents equal to each other. So x minus 5 equals 3x plus 6. And that's just a normal linear equation. We can subtract x from both sides and subtract 6 from both sides. So by doing that, we get negative 11 equals positive 2x. Divide both sides by 2, and we get negative 11 over 2 equals x. Now, example B over here, we have 3 equals 5 to the x plus 2 power. Because we only have this 5 on that side, we can't divide both sides by 5. We aren't able to do that. If there was a number in front of the 5 being multiplied, then we would want to divide everything by that. But because we have the base and exponent by itself, we want to convert this to log form. So remember, when we convert to log form, it's log base 5 of the other number equals the exponent. Logs equal exponents. We learned how to type this into our calculator, or you can use the change of base formula. Either one is okay. So if we do alpha window and then the 5th option, log base 5 of 3 is equal to 0.683. So 0.683 equals x plus 2. And then when we subtract 2 from both sides, 2 minus, it was 0.683 minus 2. And we get negative 1.317. And you could substitute these back in, but when you do that, you're not going to get exactly the right answer because we are rounding. So watch, if I do 5 raised to the negative 1.317 plus 2 power, I get 3.0019, which is close enough to 3 that we're confident we got the right answer. Now with letter C, I want us to pay attention to letter C and star it because this doesn't look like anything we've dealt with before. However, notice we have 2x and x as our exponents. This is really written in quadratic form all the way back from chapter 1 that we dealt with. So this can be solved like a quadratic equation. So let's add 12 to both sides. E to the 2x plus 7 e to the x plus 12 equals 0. So we're going to treat this just like x squared plus 7x plus 12 equals 0. Where we say, okay, what two numbers multiply to 12 but add to 7? Well, that's going to be positive 4 and positive 3. And you might say, well, in our parentheses, what do we put first? Because we would, up here, we would put x to the first power, that variable here. So we're going to put this variable as our, first term in each of these parentheses. Okay, so now we're going to set both of these equal to 0. So we have e to the x plus 3 equals 0, and e to the x plus 4 equals 0. Subtract from both sides, we get e to the x equals negative 3. Well, then we can change this to the natural log. So if we do the natural log of negative 3, that will equal the exponent x, which we know we can't take the natural log or any log of a negative number, so this does not work. And then over here, we subtract 4 from both sides. And then when we convert this to log form, another way of thinking about converting it to log form is if we take the log of both sides. So if we take the natural log of both sides, the ln of e is x, and the ln of negative 4 is just the ln of negative 4. Well, we can't have that either. We can't take the log of a negative number, so that goes away. So that means there are no solutions to this. Then letter D, we have 4e to the 3x power equals 91. Well, up here, we didn't have to divide both sides by anything because our base was by itself. Our base here is e, so we need to divide both sides by 4. So we get e to the 3x equals 91 divided by 4. And then as a decimal, see 91 divided by 4, we get 22.75. So then we convert this to logarithmic form. We have log base e, which is the ln or natural log of 22.75 equals the exponent 3x. Now you could divide both sides by 3, but we can use our calculators and just divide both sides by 3 while taking the ln or natural log of 22.75. So 22.75, close parentheses, divided by 3, and we get 1.042. All right, now let's look at the next page here. We have 3 times 8 raised to the negative 2 minus x power equals 1,293. So let's divide both sides by 3. So then it's 8 to the negative 2 minus x equals 431. Okay, now we can rewrite this in log form. So log base 8 of 431 equals our exponent, negative 2 minus x. So in my calculator, I'm going to type in log base 8 of 431, and that gives me 2.917. So 2.917 equals negative 2 minus x. Then we add 2 to both sides. That gives us 4.917 equals x. Sorry, equals negative x. And then when we multiply both sides by negative 1, or divide both sides by negative 1, because we want what positive x equals, negative 4.917. All right, now the last one before we work on some word problems is another one that's in quadratic form. So anytime you see e to the 2x minus e to the x, that's a sign that it's quadratic form. So you're going to want to remember our factoring techniques. So let's subtract 20 from both sides. So we get e to the 2x minus e to the x minus 20 equals 0. Okay, so now we got to find two numbers that multiply to negative 20, but add to negative 1, and that's negative 5 and positive 4. So our parentheses is going to be e to the x plus 4 times e to the x minus 5 equals 0. Well, for this one, we get e to the x plus 4 equals 0, and then when we subtract both sides, we get 4 from both sides, we get e to the x equals negative 4. Now, we know from the previous page that this particular situation has no solution. But we also talked at the beginning of this unit that we can never raise any number to a power and get a negative answer. Like, e is 2.7. 2.7 to any power is never going to equal a negative number. So from this point right here, we can say there's no solution for that one. If you want to, you could change that to log form, but then you'd be taking the natural log of negative 4, which isn't allowed. Here, however, we add 5 to both sides. We get e to the x equals positive 5. This we can change to log form. So we're going to have log base e, which is the natural log of 5, equals our exponent, which is just x. So then I'm going to type in the calculator just the natural log of 5. We get 1.609. So this one only had one solution because negative 4 right here, that does not work. All right, now let's look at some word problems. It says $5,000 is placed in a savings account. The interest is compounded continuously. At the end of 2 years, the balance is 5,416.5. What is the interest rate? So we're trying to find R. We know that our ending balance is 5,416.50, and because we are compounded continuously, we're using the PERT formula. A equals PERT. Our A value is 5,416.5. That was our final value. And that equals our initial value, which was 5,000 times E raised to the R power. We don't know what R is, but we know that T is 2. Oops, so 2. So we need to solve this. First, we're going to solve this by dividing both sides by 5,000 to get the base by itself. So in our calculator, when we do this, we get 5,416.50 divided by 5,000, we get 1.083. So 1.083 equals e to the 2r power. I'm going to rewrite that just so it looks more like what we're used to. Now we're going to change this to log form. So in log form, it's going to be log base e, which is the natural log of 1.083. Now here's the difference that with some of the problems above. Our exponent is 2r. So we then divide both sides by 2. You could have done the natural log of 1.083 first and then divided it by 2. But I decided to do just one calculator operation, close parentheses, divide by 2, and we get 0.038398, which we would round to 0.04. So R equals 0.04. The question didn't ask what R is, it asked what the interest rate is. So the rate is 4%, because we move the decimal back twice. Right, then example 3, the interest in a savings account is compounded continuously. R equals 8%, and the amount of the account after 10 years is $20,000. Find the initial investment and the time to double. Okay. So this is a two-part problem because it says find the initial investment first, and then how long does it take to double? So for the initial investment, it's going to be just like what we did up here, but instead of trying to find R, we're trying to find P, what we started with. So we ended with $20,000 equals A. We don't know how much we started with. Sorry, not A, P. P times E to the RT power. Well, R is 0.08 and T is 10. Now, what we can do is, since E is a number, we can just type this into the calculator. E to the 0.08 times 10 power, and we get 2.226. So 20,000 equals 2.226 times P. We'll divide both sides by 2.226, and that's going to give us how much money we started with. So 20,000 divided by 2.226, and we get 8,984, 8,984.73. So that's how much money we started with. Now we can do the second part and say, how long will it take to double? So there's a neat trick with figuring out how long it will take for your investment to double, because our formula again is A equals P times E to the RT power. Well, the thing is, if we want to know for how long it will take to double, that means that our A value right here would be 2 times our P value. So you could substitute this as 2P equals P raised times E to the RT power, and then divide both sides by P, and it would just equal 2 on the left side equals E to the RT power, and that would be easier to solve. But if that doesn't make sense to you, we can just substitute this in. Okay, well, if we have our P value is 8,984.73, if we double that, so 8,984.73 times 2, we get 17,969.42 equals our initial amount, which we calculated in the first part as 8,984.73 times e to the RT power. R is still 0.08. We don't know what t is. Okay, well, we'll divide both sides by 8,984.73. And when we do that, so this is just going to give you 2, because if you look at our calculator screen, when we multiply the original amount by 2, we got the 17,000 number. And if we take that 17,000 number and divide it by the 8,984.73, we're going to get 2. And that's because we are doubling it. So again, a shortcut for doubling would just be 2 equals e to the 0.08 t power. All right, then we can change that to log form. So the log base e, natural log of 2 equals 0.08 t. And then divide by 0.08. So then I'm going to do the natural log of 2, close parentheses, divided by 0.08. And we get 8.66 years. Right, so with these word problems, it really is required that you pay attention to what I'm asking you to solve for and what information I am giving you. So we took an application of solving these exponential equations. So thanks for watching the video. Make sure to like it and subscribe.